Alright, hello there. This is angles part 2. Types of angles. Alright, cool. So, there are 1, 2, 3, 4, 5, 6. If everybody's ever wondering, I'm looking at my notes. I post them right here so I can know what I'm talking about when I'm talking to you. So, there are 6 types of angles, alright? So, type of angle type 1, called a zero angle, okay? Why is it called a zero angle? I will tell you, audience. Zero angle. That's basically when you have, let's say, a point here, and a point here, and there's a point in the middle. Somebody give me 3 letters. A, B, and C work perfectly fine. Thank you, audience. Now, the degree measure from A to C is... I explained that wrong, didn't I? Yes, I did. Let's try this again. Scratch that. If we have blah, blah, blah. 3 dots on a line, yes? Cool. Instead of ABC, make it BAC. Why? I will explain. Because imagine we have an angle like this, right? Where it's like this. Well, imagine this is, I'm trying to do it upside down. This is A, this is B, and that's C, okay? But now imagine this comes all the way down, and then it's exactly on the exact same line as this one. Now this is what's called a zero angle, because remember my fingers in the last video? Basically, they're like this now. So they're on the exact same thing. You can call these points collinear. Coplanar is a different story. We'll get to that later. So, that is a zero angle. Then we have right angle, which is quite simple. A right angle is like this. It is given away by a line that looks like an L, and you have a box in the lower corner, and this always distinguishes a 90-degree angle, okay? What is a right angle? 90 degrees. What is a right angle? 90 degrees, okay? Cool. So, L, there's a box, 90 degrees. Now, there will be some circumstances in which there will be one that looks exactly like an L, but it will not be 90 degrees. You can't say it's 90 degrees unless in a problem it actually gives you that little box, or you can mathematically deduce that it will be 90 degrees. Otherwise, it's not. It's just a trick, and it's to visually confuse you. Not all things that you see with your own eyes make sense. Okay? Cool. Now, we have a straight angle. Now, this is what I drew originally when I was talking about a zero angle. Straight angle. This is... a straight angle is basically a straight line. From here to here, straight line. That means it is 180 degrees. From here to here, any straight line is 180 degrees, okay? Cool. So if we have A, B, C, straight across like this. A, B, C, that is 180 degrees because it spans across like this, okay? It spans across like that. Therefore, it is, if you can think of this as like a circle, let's see. If you can think of it as a circle, you start here, and you go up, and then go back, and then blah, 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 and then come back. That would be 360 degrees. Well, if you do it again, remember, you stopped right here. That's half 360. Therefore, that's a straight line from the original starting spot. Therefore, that's 180 degrees. Hence, a straight line. Who cares about that bottom? New piece of paper. We're at 4 minutes. We're doing good. Okay. Acute angle and obtuse angle. Very fun. So, what is this, children? 90 degrees, right angle. Perfect. But, let me draw the box to make it clear. Yes. See the box? Perfect. Now, if you have an angle that is dot, 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 if you have an angle like this, and you're talking about this one here, from here to here, that is an acute angle. Why? Because it is smaller than 90 degrees. What is an acute angle, children? An angle smaller than 90 degrees. Perfect. Now, if we're talking about this angle here, from here, starting here, and then it goes like this, and then goes up like that. Sorry for that terrible drawing, but I'm not an artist. I'm a mathematician. Now, that is an obtuse angle because it's bigger than 90 degrees. Anything that's bigger than 90 degrees, obtuse. Anything smaller than 90 degrees, acute. Does that make sense? I hope it does. Now, if we have 89.999 degrees, that's acute. If you have 90 degrees, right angle. If you have 180 degrees, that is a trick question. That's a straight angle. Alright, and then last but not least, the angle that always confuses me, an oblique angle. It's either acute or obtuse, not zero, right, or straight. And basically, if you really want to know what an oblique angle is, like you really think that's going to be on the test, send me an email, and I'll explain it, just for you. Alright, angle pairs. Adjacent angles, very simple. Adjacent angles are two angles that have a common vertex. Remember this? So you have a vertex. Well, basically you have it this now. No, that's a bad example. Let's say you have an X, right? Well, if you have the X, that means this angle here is congruent to this angle. Remember we went over congruence in the last bit of the video? Congruent basically means that the angle here, there, is going to be congruent, equal to the angle here. Alrighty? So those two, the top and bottom, are equal. Let's call this A. Let's call this B. Just for showing you demonstrational purposes, let's write it out. If we have angle A, that is congruent, we draw the squiggly line on top. Angle A congruent to angle B. Now let's say angle A equals 35 degrees. That means angle B, measure of angle B, and measure of angle A equal also 35 degrees, okay? So if measure of angle A, that's how you write it, M, the angle sign, A equals 35 degrees. And measure of angle B equals 35. That means that angle A is congruent to angle B. Now the way you write it would be measure of angle A equals measure of angle B. Alright, that is how you write it. Angle A congruent, that means the squiggly lines on top of the equals, angle B. Measure of angle A is equal to measure of angle B. That concludes part 2. Ready for part 3?